couldn't remember what it was. But yeah, this is a good solution. At least on my end, it's indistinguishable. I don't know if you can tell the difference or not from your end. You don't have to sit there with a phone up next to your ear, do you?
No, it's fine. I'm on speaker.
Okay. Okay. So, we got the sum, right? You know how to get a number from that.
Yeah.
Okay. What else we got in the way of sequences and stuff?
I just wanted to do some of the geometric sequences here.
Okay.
So, I'm trying to find one that looks not arithmetic. Okay. This one says 72, comma 9, comma 9/8, comma 9/54. Yeah, and then dot 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 72 times 1/8 the power of 7.
Do we know how many terms there are? In other words, first of all, let's look at geometric series. What's the nth term formula?
Okay, so a sub n is equal to a sub 1 times r to the power of n minus 1.
Looking at that last term, what is n going to be?
Would it be 8?
Yeah. So n equals 8, because they were nice enough to tell us. If they would have actually put a number in there, it would have been much harder to figure out. We could still have done it, but we'd have to incorporate logs and all of that stuff. We'd have to use logarithms to solve it. And you probably have another one that does have a number in that spot, because I've seen it from other students. And we can look at that one. You got one that's got the number 39,000 and something in the last spot? Do you have that problem?
No.
Oh, okay. Well, you don't have exactly the same problems, but this is particularly easy only because the way they defined the nth term tells us what n is. In other words, it's a sub 1, 72, times the common ratio, 1/8. Well, if it's n minus 1 and we're looking at a 7, then n must be 8. So now what is the sum of the n terms for a geometric series? Remember, they all begin with that.
Yeah. So
what's the rest of it? This is the hardest one. This is the hardest one to memorize.
Yeah. So then a sub 1 times.
There it is, right there.
1 minus. Okay.
Okay, and we know everything. We know a sub 1 is 72. 1 minus the common difference is 1/8, or the common ratio, to the 8th power.
Okay.
All divided by 1 minus 1/8. So there's the sum of the numbers. You might have to use a calculator to figure it out, but
Yeah.
now, if they would not have been so kind, in fact, put this in your calculator. Take 1/8 to the 7th power, multiply it by 72, and what do you get? Let's make this problem tougher.
72. Oh my goodness, that's a really big number.
No, it shouldn't be. It's 1/8 to the, or excuse me, it's 1/8 to the 8th power. which is going to be a really small number. You have to do this a little different. In fact, take 0.125. That's 1/8. Take it to the 8th power.
1/8 to the 8th power?
No, to the 7th power, excuse me.
Okay.
And then multiply that number by 72.
Okay, that's better. I don't know what happened the first time. It was terrifying.
Well, I do, because I'll bet you did this. 1/8 to the 7th.
No, I just put it in.
No,
I thought we multiplied.
in other words, if you're going to take 1/8, you got to put parentheses around it and raise that to the 7th power, like that. And then multiply it by 72. What do you get?
I get 9 over 262,144.
262,144, like that?
Yeah.
So,
Not cool. Just like 200,000 or 260,000.
144. Okay, all right. So let's say they gave this as the problem. Well, now it's not so easy to figure out what n is, right?
Yeah.
Becomes a far more difficult problem, the fact that they gave us a number instead of something to the 7th power. When they give it to you to the power, you can just plug it directly into here to figure out what n is. Well, when they give it to you like this, and you might get something like this, so I think it's worth covering. We have a sub n equals a sub 1 times, because it's geometric, common ratio to the n minus 1. So our goal is to solve for n, because we can't answer what the sum is unless we know what n is. Well, we know what a sub n is. That's 9 over this number. We know what a sub 1 is, 72. We know the common ratio is 1/8 to the n minus 1. So now we have to solve that equation. Notice that we're looking at an equation that only has one variable, n.
Okay. So you would start by dividing by 72?
Okay. And then what? So I'm just going to write that. We don't need all these big numbers. I'm just going to write it like that. Okay? Now what?
Would do a log?
Yeah. In other words, when you're solving an exponential equation, you need to use logs. So we would take the natural log of both sides. So I've got on the left side the natural log of this horrendous number. But we can certainly figure out what the natural log of that is. It's just a number. That's equal to the natural log of 1/8 to the n minus 1. And now what can I do with the n minus 1?
You can... Oh, there's a rule in it.
Yeah, you can take the exponent and put it down on the algebra line. In other words, I can take this n minus 1 and put it here. In parentheses. Take it away from the exponent. That's the same thing. Now I'm going to divide both sides by natural log of 1/8. And that whole thing is going to be equal to n minus 1. So n would be this quantity divided by this quantity plus 1. So when I get done with the whole thing, I've got n equals and we will discover that n is 7. Excuse me, 8. In other words, the answer to this is going to be 8. Because they gave it to us in a simple format where you could figure out what n was and we were able to figure out that it was 8. I went back and made it harder just so you'd know how to do a hard one if you got one. Okay, and there are some like that. I don't have it anymore. I had one last night that was very much like that, and they gave it a geometric sequence and they gave some giant number there instead of the way it was given to you. And so they might give you a sequence like this and say, solve this for the sum of this. Then you'd have to do it the hard way. Okay, got another one? We only got like a few 5 or 6 minutes here. You want to stick and do some more sequences and stuff? Do you have any others you want to look at?
I think I'm good.
Okay.
We have time for like ACT here.
Yeah, we do. We got plenty of time for that. I got it. We ended the last test, which was test 4. Question 16 was the last question there. And we've done that one. It was a Venn diagram problem. Number 16. And let's just review that because these are some of the hardest problems on the test, or the Venn diagram problems. When you have 3 possibilities, in other words, we have set x alone, we have set y alone, and we have an overlap. That's when we want to start drawing Venn diagrams. Here's set x, there's set y. This is the people that are in both sets. Now, this tells you that x plus 2b is all of this. This tells you that y plus 3b is all of that. So if y plus 3b is the whole right circle, and x plus 2b is the whole left circle, and they tell you that there are b members in common, so I know this is b, well, that means the rest of it must be x plus 1b, and this must be y plus 2b. Did you get that part about it?
Yeah.
And so it's saying how many elements are in the union of x and y but not in the intersection. Well, that's all of this plus all of this, which is x plus b plus y plus 2b, or x plus y plus 3b. Now, you can also have Venn diagram if there's 4 possibilities. In other words, they may give you a problem that says you have set x, you have set y, you have the combination, and then you have part of your members aren't in either x, y, or the union. So they're outside here. So let me just, let's do this. Let's say you have 200 students. You have 75 taking Spanish. You have 60 taking French. You have 10 taking both. which leaves 55 taking neither. If I were to draw a Venn diagram of this situation, I would start with a rectangle with the two circles inside, overlap. This is the Spanish, this is the French, there's the 10 of both, and 55 is everything outside the two circles.
Okay.
So if I wanted to know how many Spanish, I've got 75 minus 10. So there's 65 taking Spanish alone. There's 50 taking French alone. And there's 55 taking neither. And there's 10 taking both. All of those should add up to 200. 65, 10, 50, and 55. I don't know what I did with my math, but how can that not add up to 200? I thought this added up to 200. Doesn't that? 135, 145, and 55. Ah, that's because I didn't analyze it with a Venn diagram properly. No, this is correct, actually. You would have 65 students taking... No, it's not correct. No, this would have to be 85. And this would have to be 70. And now 70 plus 85 plus 10 plus 55 add to 200. And there are a total of 85 people taking Spanish. There's a total of 70 people taking French. There's a total of 10 taking both and 55 taking neither. And those have to add to 200. So sometimes your Venn diagram has two circles and a combination. Sometimes it has three circles like this and no rectangle. In other words, you have three different languages, and you have, say, this one is German. And you have some people taking Spanish, some people taking French, some people taking German, some people taking German and French, some people taking Spanish and French, and some people taking all three. Right there is all three. So that's the essence of Venn diagrams, is for handling problems like that. This.
Okay.
And that's probably as hard a problem as you're going to come across on the SAT, I would think. So that's a good place to stop. Okay? I will talk to you next Tuesday, Sarah.
Awesome. Sounds good. Thank you.
All right. Bye-bye.